problem states to write a function to model the cost of the enclosure as a function of the length of the fence. Therefore, the cost is affected by the length and material of each side. So the independent variable is the length of the sides and the dependent variable is the cost of the materials. To create the functions, several formulas are needed. For our specific problem, we identified that area and perimeter formulas were necessary to derive the function. The problem stated the area of the rectangular patio was 400 feet squared. Therefore, length times width equals 400 feet squared. The second formula we used was perimeter. By incorporating the material cost for each side, we came up with the formula 15L plus 2 times 20W plus 20L equals perimeter. Because we are writing our equation as a function of length, it was necessary to revise our function to only include variables representing length. To make this happen, we used our area formula and solved for width, so there would be a value to plug in for W. In doing this, we found that W equals 400 feet squared divided by L.
After plugging in this value, the function became 15L plus 2 times 20 times 400 feet squared over L plus 20L. Next, we appropriately distributed the two and combined like terms, so our final function for cost as a function of length equals 35L plus 16,000 over L. We chose to use Desmos to present the graph of our function. We kept our window at x is greater than or equal to 0 and y is greater than or equal to 0 because realistically there are no negative lengths.
To find the minimum cost of the enclosure, we understood that we needed to find the minimum point on the graph. The minimum coordinate had an x value of 21.38 and a y value of 1,496.66. To answer the question B, the length to minimize the cost would be 21.38 feet. Question C asks what lengths of fencing would lead to a total cost of $3,000. Since cost is a y value, we plug the equation y equals 3,000 into Desmos. In doing so, we observed two intersections. One had an x value of 5.714 and the other had an x value of 80. Both length measures will lead to a cost of $3,000.